The famous tagline for the movie Alien famously stated, "In space, no one can hear you scream." For decades, this has been the gold standard for our understanding of the cosmos, a cold, dark, and utterly silent vacuum. We are taught in middle school physics that sound is a mechanical wave, a vibration that travels through a medium like air, water, or solid metal. Because space is a vacuum with vast distances between particles, there is nothing for those vibrations to hitch a ride on. If a star explodes in a supernova, it doesn't make a boom. If two galaxies collide, they do so in a haunting, hushed stillness. But what if I told you that this popular narrative is only half true? What if I told you that the universe is actually screaming, humming, whistling, and roaring with a complexity that would rival the most intricate symphony ever written? The truth is that the universe is not silent. We have simply been deaf to its music. To understand the sound of space, we first have to redefine what we mean by hearing. Our human ears are biological instruments designed to pick up changes in air pressure. When we talk about the sound of space, we are often talking about two things: actual acoustic waves traveling through thin gases, and the process of sonification. Sonification is the practice of taking data such as radio waves, X-rays, or gravitational ripples, and translating them into sound frequencies that the human ear can perceive. When we do this, the results are nothing short of breathtaking. We find that every celestial body, from the smallest moon to the most gargantuan black hole, has its own unique voice. If you were to step outside a spacecraft and tune your senses to the electromagnetic spectrum, the silence of the void would instantly be replaced by a chaotic, beautiful, and sometimes terrifying wall of sound. Let's start with the most dominant voice in our neighborhood: the sun. Even though the space between Earth and the sun is a vacuum, the sun itself is far from quiet. It is a roiling, turbulent ball of nuclear fusion and magnetic storms. Scientists at the Stanford Experimental Physics Lab have been studying the seismic waves of the sun for years. By tracking the vibrations of the solar surface, they have been able to capture a deep, low-frequency thrumming. If you could hear it, it would sound like a giant bell ringing every 5 minutes, or a massive subterranean engine idling in the distance. This hum is caused by the constant motion of hot gases inside the sun, and it is so powerful that it causes the entire star to pulse like a beating heart. It is a visceral grounding sound that reminds us that our life-giver is, in fact, a violent and active furnace. Moving further into the solar system, we encounter the planets, each with its own distinct radio signature. Because many planets have magnetic fields, they interact with the solar wind, a stream of charged particles from the sun, to create radio emissions. NASA's Voyager and Cassini probes carried instruments to detect these waves, and when converted into sound, the results are haunting. Jupiter, the king of the planets, sounds like a haunted ocean. It produces complex whistlers and chirps caused by lightning in its atmosphere and the interaction of its moons with its massive magnetic field. Listening to Jupiter is like listening to a 1950s science fiction sound effects reel. It's a series of sliding tones and crackling static that feels incredibly alien. Saturn, by contrast, has a more ethereal, ghostly sound. Its radio emissions, known as Saturnian kilometric radiation, sound like a cold wind howling through an abandoned canyon, punctuated by high-pitched, eerie shrieks. But perhaps the most terrifying sound in the universe comes from the one place we expected to be the quietest: a black hole. For a long time, we thought black holes were the ultimate silence, the end of all things, including sound. However, in 2022, NASA released a sonification of a black hole in the Perseus galaxy cluster that went viral for being genuinely unsettling. Unlike other sonifications that translate light into sound, this one was based on actual pressure waves. The Perseus cluster is filled with vast amounts of hot gas that provide a medium for sound waves to travel. Astronomers discovered that the black hole at the center was sending out ripples in this gas. When these ripples were scaled up by 57 octaves so that humans could hear them, they revealed a deep guttural moan. It sounds like a chorus of thousands of voices trapped in a void, a dark and brooding rumble that feels like the very definition of cosmic horror. It is a reminder that gravity is not just a force. It is a physical warping of reality that can vibrate the fabric of space itself. If we venture even further out, past the planets and the stars, we reach the edge of the interstellar void. In 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the sun's influence ends and interstellar space begins. As it crossed this threshold, its instruments detected a sudden increase in the density of plasma. When this data was converted to sound, it produced a rising, screeching tone. This was the sound of the interstellar wind. It was the first time humanity had heard the environment outside our solar system. It was a sharp, piercing sound that symbolized the loneliness and the vastness of the journey that lies ahead for our species. It was the sound of the great unknown. But what about the beginning of time itself? Can we hear the Big Bang? Surprisingly, the answer is yes. About 380,000 years after the Big Bang, the universe was filled with a dense, hot plasma. This plasma acted like a fluid, and sound waves could travel through it. These were not just small sounds. They were massive pressure waves that shaped the very structure of the universe, determining where galaxies would eventually form. Today, we see the echo of these waves in the cosmic microwave background, CMB, the leftover heat from the birth of the cosmos. When scientists translate the CMB into the audible range, it sounds like a thick white noise hiss, similar to the static you used to hear on an old television between channels. This is the static of creation, a constant background noise that has been ringing through the universe for 13.8 billion years. It is the oldest sound in existence, the literal opening note of the cosmic symphony. In recent years, we have discovered a completely new way to hear the universe through gravitational waves. In 2015, the LIGO Observatory made history by detecting the ripples in spacetime, caused by the collision of two black holes over 1 billion light-years away. This was not electromagnetic radiation. This was the actual fabric of space stretching and squeezing. When these gravitational waves are played through a speaker, they produce a very specific sound, a chirp. It's a short rising tone that lasts only a fraction of a second, but it represents one of the most violent events in the universe. Detecting gravitational waves is like humanity finally opening its ears after thousands of years of only being able to see. We can now hear the thuds and clangs of black holes and neutron stars colliding in the dark, events that were previously invisible to our telescopes. It has opened up a whole new soundscape of the universe that we are only just beginning to explore. While the universe provides its own music, humanity has also tried to add its own voice to the mix. In 1977, NASA launched the Voyager 1 and 2 probes, each carrying a golden record. This was a copper phonograph record containing sounds and images selected to portray the diversity of life and culture on Earth. It includes the sounds of rain, thunder, birds, and whales, as well as greetings in 55 languages and music ranging from Bach to Chuck Berry. There's even the sound of a mother's first words to her newborn child and the rhythmic thumping of a human heartbeat. We sent these sounds into the void as a message in a bottle, hoping that someday, millions of years from now, some alien civilization might find them. It is a touching thought that in a universe filled with the roars of stars and the moans of black holes, there is a tiny gold-plated disk carrying the sound of a cricket on a summer night or the laughter of a human child. It is our way of saying, we were here, and this is what we sounded like. The study of the sound of space, whether through acoustic waves in gas or the sonification of light, does more than just satisfy our curiosity. It changes our emotional connection to the cosmos. When we look at a silent image of a nebula, it feels distant and abstract. But when we hear that same nebula, perhaps translated as the twinkling of bells or the swell of a violin, it becomes intimate. It feels like a place we could visit, a place that has a mood and a character. Sound is a powerful tool for accessibility, allowing people who are visually impaired to experience the wonders of NASA's discoveries. But it is also a tool for scientific insight. Our ears are remarkably good at detecting patterns and anomalies that our eyes might miss in a graph or a photo. By listening to the data, astronomers can sometimes hear a discovery before they see it. So, what would you hear if you were in space? If you were relying on your biological ears, you would hear the sound of your own breathing and the thud of your heart against your ribs. You would hear the hum of your suit's life support systems. But if you could transcend your biology, if you could tune into the magnetic fields of the planets, the seismic pulses of the stars, and the gravitational ripples of the deep void, you would find that space is the loudest place imaginable. You would hear the frantic pinging of pulsars, spinning stars that act like cosmic lighthouses, ticking with the precision of a clock. You would hear the she of the solar winds sandblasting the atmospheres of planets. You would hear the symphony of a billion suns, each contributing its own vibration to the grand tapestry of the night sky. The universe is a vibrantly noisy place, a vast resonance chamber where everything is connected by waves of energy. From the subatomic vibrations of particles to the galaxy-spanning ripples of gravitational waves, everything is in motion and everything has a frequency. To ignore the sound of space is to miss out on half of the story. We are beginning to realize that the vacuum is not a nothingness but a stage, and the silence is not an absence but a potential. As our technology improves and our ears become more sensitive, we will continue to uncover the melodies hidden in the dark. We will find that the great silence of the Fermi paradox might not be because there is no one talking, but because we haven't been listening in the right way. As we look toward the future of space exploration, sound will play an increasingly important role. Astronauts on long-duration missions to Mars might use the sonified data of their surroundings to stay connected to the rhythm of the universe or to monitor the health of their spacecraft by listening to its mechanical vibrations. We might even find that certain sounds like the low-frequency hum of the Earth's ionosphere can have a grounding, psychological benefit for humans living far from home. We are creatures of sound, and as we move into the stars, we will take our music and our listening with us. In conclusion, the next time you look up at the stars on a clear, dark night, don't just see the light. Try to hear the distance. Imagine the deep rumble of the sun, the ghostly whistles of Jupiter, and the ancient hiss of the Big Bang still echoing through the trees. Understand that you are standing in a magnificent concert hall, and even though the air is thin and the vacuum is vast, the music is playing all around you. The universe is speaking in a language of waves and frequencies, a cosmic dialogue that has been going on for billions of years. Our journey into space is not just about seeing the sights. It is about finally learning how to hear. In the end, we may find that the most beautiful sound in the universe is not the roar of a supernova or the chirp of a black hole, but the simple, quiet harmony of a planet that is finally beginning to understand its place in the choir of the stars.